guys are going to come up with a equation that fits all these clues. It has to, the solutions at the end have to be 5 and negative 5. It has to be an absolute value equation, so somewhere in there has to be absolute value. There has to be a 2 in there somewhere, and you have to be subtracting in there somewhere. So you can use your absolute value equation notes from last time to kind of help you set that up, to kind of help you think about how you would need to solve it in order to get those solutions and things like that. You can work together. You can double check yourself in the calculator in Desmos, use the desk, use each other, your notes, all those things, and I'll give you like 5 to 10 minutes to work through that. Anyone have any questions on that? Not that it's a competition, but so thank you, Russell, Charlotte, Mohammed, Lily, and Matthias for these equations. I'm going to write these up and then show you some other ones that other students came up with. Let's start with these. Matthias, this one's yours. So with this one, we could add 2 to both sides. Drop the absolute value. Set it equal to a positive and negative. Oh, I missed that part. But I think it should still be. This one's hard to see because it's on that. But when we divide both by this negative 10, we end up with negative 5 and positive 5. So that one. Right? Some were as complex as that. So a lot of these ones are very similar, just written a different way. Russell came up with this one, adding 3 to both sides. And then dropping the absolute value, and that would make that the plus minus. Charlotte came up with this one, similar to that one, but opposite. Now adding 2 to both sides. And then we would drop the absolute value, get the solutions, and that would be the plus minus 5. For this one, Mohammed came up with this one. If we subtracted 2 on both sides, we'd end up with a negative, but because there's a negative on this side and we divided both by negative 1, then we get the same thing. And then Lily came up with this one, adding 12 to both sides. Let's write this here for all space. And then the rest will be the same. So good job on those. Some others that first period came up with, the absolute value of 2x, and then outside of that, minus 5 equals 5. I'll write these down, but I'm not going to solve them. 2 times the absolute value of x equals 12 minus 2. This one is like almost, we just need to simplify that, but the subtraction still works. And then 5x minus 2 equals 23. So we had some more complex ones, we had some simple ones, so good job on that. I know that was kind of hard, trying to remember, okay, how does absolute value work? How could I get these solutions? What could make them get these solutions? I could subtract it in there somewhere, and it still doesn't get these solutions, but good job on that. about our last lesson before your quiz on Thursday, your test on Monday, which is literal equations. So first, I want you to look at these two sentences and tell me what's the difference between it's raining cats and dogs and it's literally raining cats and dogs. There are actual cats and dogs raining from the sky. Yes. The figurative, it's an exaggeration. It's raining so hard, cats and dogs could be falling from the sky. That's how hard it's raining, but it's not actually. The second one is actually happening. So when we talk about the word literal, these are some more examples of that. And these are on your page as well. But the word itself, literal, is actually, or without exaggeration. But a literal equation is very much like a multi-step equation. You solve it like normal, but you don't get a real answer. You don't get a numeric answer. You literally solve it. You actually solve it, but not to get a numeric answer. It's weird. Your answer is going to be just a bunch of letters rearranged for whatever we solve for. But that's our goal, to try and see if we can solve these literal equations by rearranging them to solve for different variables. So go on to the next page. And I want you to take a second and read through these helpful hints. Many of these are similar to how we would solve a regular equation, but we're not going to get number answers. So we just have to think about, if this were a regular equation, how would we start to solve this? So we're going to have regular equations, solve those, and then have literal equations with just variables. This is very much in my way. Okay. So with this first one, this regular equation, we have 2x equals 10. How would we get x by itself? Divide both sides by 2, so that x equals 5. But now if we had something like example 2, where we have nothing but variables and we're trying to get h by itself, how would we get rid of g? Divide both sides by 2. So very similar. The g's here are going to cancel. But m and g are not like terms, so you're just going to rewrite that. H equals m over 10. We have literally solved this problem so that it's rearranged for different variables. It's going to be weird. It's going to take some getting used to because we're not getting an actual answer. Do you have any questions on that one? Try the next one. 2x plus 5 equals 11. If we're solving for x, what would be our first step?
Minus 5.
We have 2x equals 6, and now this looks just like example 1. You divide both sides by 2. Now let's take that same process for ax plus b equals c. If we're solving for x, what would be our first step? Subtract b to the other side. When we do this, c and b are not like terms. We cannot combine them, so we just rewrite it. And then to get x by itself, divide everything by a, just like we did here. Again, nothing here is like terms with a or can be simplified, so we just divide everything all at the same time. So x would equal c minus b all over a. We have literally solved this equation for a different variable. Questions so far? Now let's pick it up a notch. Now we have letters and variables. We're still just going to get an equation or a formula that has numbers now with variables, but the process is the same. And number 5, we were trying to get x by itself. What would be our first step?
Subtracting.
If we were subtracting 3, we'd have to subtract this entire thing since x is connected to it. And then that wouldn't really help us get x by itself. So we just move to the other side. We can get rid of the 6y because that has nothing to do with the x. And we have to move it all together. So we can add 6y to the other side. 17 and 6y are not like terms, so again, they're not combining. Whether you put 6y plus 17 or 17 plus 6y does not matter. And then to get x by itself, divide everything by 3. However, if this 3 can go into any of these numbers and be simplified, you have to divide them separately. We have x equals 17 over 3 plus 2y. Have any questions on how we solved that one? Or about how we solved it? I want you to take the next minute or so and do example 6. What would the first step for example 6 be? Minus 3x, both sides. Again, not like terms, we're just rewriting. And then to get y by itself, divide everything by -6. Because this is going to simplify, but be careful because all your signs need to change. We have y equals -17/6 plus 1/2 x. Make sure your negatives are either in your numerator or out front, not in your denominator. Do we have any questions about that one? Now, in example 7 and 8, they're just like 5 and 6, but now it's only variables. So number 7, if we were solving this for c, how could we get it by itself?
Minus AB.
Get rid of the term that has nothing to do with it. Subtract it to the other side. G minus AB, they are not like terms, so you're just going to rewrite. And then divide everything by 8. These are not, cannot be simplified, so you're just going to divide everything all at once.
I think you forgot to get rid of it.
Yep, you're right. I did. I wrote it and I was like, wrong, but didn't register my brain. Okay. Do we have any questions about 7? Do number 8. For A, what would be our first step?
Minus CD.
Minus C, the other side. We have AD equals G minus CD. And then
B.
G minus B all over B should have been right. Once you have that, go on to the next page. And I want you to find any that look challenging, you want to go over together, you have questions about any of them. So, six, Chelsea. Ashley, please. Alright, let's start with those. If we have any others, we'll go back. So number 2, we're solving for t. So we gotta get rid of the p that's by itself and the p and the r in front of t. What would we get rid of first? The p that's by itself has nothing to do with this term, so we can subtract p to both sides. So we have a minus p equals prt. And then to get rid of p and r, we could do what? Divide. We can do that all at the same time. Divide everything by p and r all at the same time. So we have a minus p all over pr equals. Have any questions about that one before we go on to the next one? And number 3, we are solving for f. You have 2 choices here. You can either distribute the 5/9 and then deal with that, or you can get rid of it. Which would we rather, distribute or get rid of it? Okay. So if we're going to get rid of it, we need to move it to the other side. The only way to do that is to either divide both sides by 5/9 or multiply by the reciprocal. I'll let you choose which one you would rather. I'm going to flip it and multiply on both sides. So that the 5/9 and the 9/5 cancel on the right. And we have 9/5 C. The parentheses drop. And then to get f by itself, add 32 to both sides. We have 9/5 C plus 32 equals f. Some of these formulas may or may not look familiar. This one is how to convert Celsius to Fahrenheit and back and forth. Questions on 3 before we do 6? Here, because this one has a C and this one doesn't, so they're not different. But if they both had C's, then yes, we would add them together. Number 6, what are we solving for?
E1.
Or b sub 1, your choice. So again, we have this 1/2 on the outside. We can either get rid of it or distribute it. I'm going to get rid of it for this case, so this makes life easier. So I'm going to take it and flip it and multiply on both sides. So that the 1/2 and the 2/1 cancel. And we can simplify. This would just be 2a equals h times your parentheses plus b1. The way I said that was so weird. Anyway, I rewrote it. Then how could we get rid of the h? Sure, we could do that. We're going to end up with an h with b1. We're going to have to go back. It's going to get messy, but we can do that. I'll show you the other way we could have gone afterwards. this case, we would subtract the HB2. We have 2a minus HB2 equals HB1. And then to get rid of H, how could we get rid of the H that's with B1? Would be sub 1. But because we now have an H over here, we have to do this individually. So instead of distributing, if we had divided both sides by H here, I'm just going to write this over here. You can write this in use of twos. If we had divided both sides by H here, then we have this part, 2a over H. And then we would have just subtracted the B. So it doesn't matter how you do it, as long as it makes sense mathematically. You're going to get the same answer both ways. But also, if you just divided everything by H, it would be simplified. Like everything at once, instead of separately. So you have to be careful and mindful of those things. Do we have any questions on, any other questions on 6 or other questions on this page in general? Okay.
When we get rid of negative, we get rid of 1/2.
Mm-hmm.
What is the two numbers?
So when you divide by a fraction, in the calculator, it's the same thing as multiplying by the reciprocal. So if you divided by 1/2 instead of multiplying by 2, it's the same thing. Now, if you divided by 1/2 as you're writing, you're going to have to leave it as a over 1 over 2, and then it gets confusing as you keep solving. So multiplying in that case would be better, especially for literal. Other questions on this page? Go on to the next page. There are some more practice problems. Find any that look confusing you want to do together, you have questions about. Four are so you have one. So we'll start with those. Do we have any others? We'll go back. So number 3, we're solving for x. What would be our first step?
Plus 6.
So we have y plus 6 equals 5x. When we go to divide by 5, are we going to divide separately or all at once? Is there something that could simplify with the 5 that we would need to divide separately, or could we divide all at once? We could divide all at once. So y plus 6 all over 5 equals x. Those are the questions you need to be asking yourself when you go to divide. Will this simplify? Will any of these simplify? If so, divide them separately. If they will not simplify, you can divide it all at once. Okay, number 4, we have to get m by itself. What do you think would be our first step? denominator, if you have one, multiply it to the other side. So you have 2k equals mv squared. And then to get rid of the v squared,
plus 2v.
so what operation are these doing already? Divisible, yeah, so to undo that, we wouldn't subtract, but divide. If this asks us to solve for v, then we have to get rid of the square, but it didn't. So we don't have to worry about that. It can still be squared. So 2k all over v squared equals m. Questions about that one before we move on? Number 5, what are we solving for?
Z.
Z. We have to get z by itself. It's helpful to know what you're solving for, especially when it has a bunch of variables. What would be our first step? What would we get rid of first? Yes. Get rid of the 2a. It has nothing to do with the z. And then in your literal, you can rearrange this in ABC order or leave it as is. It does not matter for this one only. So I'm going to rearrange those in ABC order. And then when we go to divide by 9, are we doing that all at once or separately? Separately because of the 3. If this were any other number like 7, we could do it all at once. So z equals -2/9 a plus 1/3 j minus 4/9 x. Make sure you are simplifying. It will change how your answer looks. We want it as simplified as possible. Do you have any questions on 5? Number 7, we are solving for r. What do we think would be our first step? Divide by. We have a over pi equals r squared. And then how could we get rid of the squared? How we undo something that's squared. Is that what you said? I didn't hear what you said. A over pi. So since we're square rooting one side, we have to do it to the other side. Properties of equality. The square and the square root cancel, and then we just be left with 1. And the square root of a over pi equals 1. Were there any other questions on this page?
What would happen if we done 3J?
Oh, like if you look at it like this? For this test, this quiz, that's fine. Moving forward, we're going to make sure we're putting things in ABC order, but this one is okay. I want you to try a few problems. Number 1, number 2, and number 8. Try those. see if your answer matches the people around you. If you've already tried them, raise your hand and I'll come check them. And then we'll come back and talk about them, and then I'll explain the last one we're doing today. Some of you distributed, some of you divided, but at the end you should have still got this. If you have any questions about that one. Anyone want to do number one? For number one, you should have just been dividing by I and R on both sides. So that we get P over IR equals. How many of us got that one? Anyone want to come do number 8? So for the most part, that one was just like number 5, except when you started to solve things, you ended up with a negative. So we're solving for x, we could get rid of the 3j by moving it over. Whether you rearrange this or not is up to you. I'm going to rearrange it just because. Then after you subtracted, you would have needed to divide everything by -4, so all of your signs would have changed. If the 2 was a 3, you could have divided everything all at once, but because this can be simplified, you would have to change this. So -1/2 a plus 3/4 j minus 9/4 z equals x was your final answer. Questions on that one? The last page, sorry, do you have a question? Okay. The last page has a word problem, but it's like not realistic for how literal equations work, so we're not doing that. I do want you guys to grab one of these. So it has like what we started off with, solving a regular equation and then solving a literal equation, and then some just literal equations on the back. Do that. Raise your hand when you finish, and I'll check it. You can work together. You can use your notes. You can use your calculator. It wouldn't really help you for the literal part. And then when you finish, if you haven't done the Delta math that's due on Friday on literal equations, you can be working on that. After that, time is yours. But make sure you're working on the Delta math.